If you enjoy Astronomy FM radio, please let us know with a small donation. We do rely on your support, and it's true. Every little bit counts.
AFM. You're listening to AFM radio on Astronomy.FM. Around the world and beyond.
Coming up next, it's time for an AFM radio original program, Space Pirate Radio, brought to you by the voice of astronomy, matey. This is Astronomy.FM.
The pirates are coming. The pirates are coming. The pirates are coming. You better watch out.
Arr!
Arr!
It's Space Pirate Radio time. Buckos here on Astronomy.FM radio. That means it is another Wednesday evening. This one just happens to be October the 11th, 2017, 9:01 in the evening for those of us here in the eastern portion of North America. So that would put it at universal time of 1:01 in the morning of October the 12th, Thursday morning, 2017. So, of course, that means we are live right now and for the next hour. And that means time for the crew to start boarding. So everybody listening out there, join us in the Astronomy.FM chat room, which you can go to from the homepage or type in Astronomy.FM/chat. Either way, we'll get you to the login. Type in a name, hit login, and you'll be here. Welcome aboard, everybody that's here so far. We've got you and me. We've got Glenn, Twist Edge, Aqua for you, Doug at Northern Cross Observatory, Plaid Joan, Optronics so far. Board quickly, everybody, because as soon as you're on board, we're going to set sail and hard to starboard. We got a rock coming in. We have to avoid the rocks. Coming in close, let's see, this asteroid is called 2012 TC4. Passing by, well, kind of today, pretty much. I don't have an exact time. It's close to approach. Not really big, maybe, I don't know, 50, 60 feet, something like that. 90 feet, maybe. Anywhere in that range. Yeah, 45 to approximation. Yeah, 45 to 100 feet, approximately. So, but it's going to be pretty close, passing by at about 26,000 miles from the Earth. Just outside the range of geosynchronous satellites. They hover around at 5,000 miles. So it'll be not that much of a near miss. It'll be a good couple 1,000-mile miss, which is what's that, quarter of the year's diameter. But close, much closer. That's about how far away it'll be from us. So it seems kind of close when you put it on that scale, though, doesn't it?
It seems pretty close, yeah.
Yeah.
Bit of a shame. Actually, I was rather surprised because this one snuck up on me. There's been a lot going on that's not astronomy related in my life. And so my boss actually walked by my desk on Tuesday and he said, "Hey, I hear there's this rock coming by." And I didn't know about it. So But so I figured you'd know.
Yep. The distance to the Earth will actually be 26,000 miles. So that's like 3+ Earth diameters. But it's only a couple thousand miles away from the regular satellites.
So if you're looking to see it, the best viewing prospects of North America, it's on October 11th, which is tonight if you're in our time zone.
Yes.
It's going to be in the south. It's going to be in Capricornus and Microscopium and Sagittarius. So we're talking low on the southern horizon here.
Mm-hmm.
Southern hemisphere observers get a great view, and it's going to be particularly nice in the pre-dawn hours of October 12th. So if you are in the southern hemisphere, in South America specifically, check it out. And there is a handy online tracker that we can share with you guys.
Is it really? You got that?
Yep. The skylive.com, has an online tracker. So if you are in a position to be observing, check it out.
Cool. Let me pop that.
As Aqua for you is saying, you're going to need to know the timing and the sky location dead on. You will not be able to spitball this. It's too small.
Yep. One report says you could be able to see this in an 8-inch telescope. Maybe one report said it's going to be 17th magnitude.
I am not seeing a 17th magnitude object in my 8-inch telescope. Sorry.
No, me neither. This one's reporting 13.9, so about 14 magnitude.
With a dark sky, I could probably pull that off. And with a dark sky, I could pull that off. Yeah, 6 magnitude dark.
Super dark skies. Yeah, like mountaintop skies and totally steady atmosphere, things like that. That's right on the edge. I've never seen Pluto in an 8-inch. Had a tough time.
Once.
tough time seeing it in a 12-inch.
I could see it in an 8-inch from a 6th magnitude dark sky sight when it was in front of a dark nebula.
Mm-hmm.
Good luck.
Yeah. So this one's going to be, definitely a challenge, but, fun little thing to give it a shot, see if it's possible to pick this one off. So give it a shot. But you're going to have some good equipment and some super dark skies. And it's going to be moving, too.
Right.
Fun one.
So Glenn asks, is this going to be astronomical close or my goodness close? I would say both.
Yes.
I mean, if you're talking about within range of the geosynchronous satellites, that is a my goodness close.
Mm-hmm.
Fortunately, it's pretty small.
It is. So we could easily handle the impact. Chelyabinsk was just a little bit smaller than this one.
Yep.
Of course, it depends on the makeup of the thing.
Yeah. So
yes.
if it were iron, if it were solid iron nickel, that would not be good. If it is a rubble pile, it would be a window rattler, but it's not going to wipe out life as we know it.
That's correct.
Or even the city.
That's correct. So it's a window buster.
Yep.
And again, depending on the composition and the actual size. Now, one thing these asteroids do with this is it does help a network of near-Earth asteroid alert systems to sync together, and they'll be tracking this asteroid using multiple different types of equipment for exact positioning. It's basically a practice session when they get close like this. The more exactly they can measure its position and measure how close it gets as it passes by us, the better they'll be able to do the same thing with big ones that might be hitting us and might not be hitting it, that can't really tell from a far distance. So it's a practice of a coordination of a system of astronomers that will help them coordinate together and see, if something's going to hit us, well, if it's going to be missing by 100 miles or not, this is the kind of stuff that they need to practice on for the really, really close ones. This one's not that close, and a really, really big one, too. So if you got one that's a mile in diameter, it's going to pass within, 100 miles. We really want to know that it's actually going to pass. So there'd be a big network of astronomers. Mm-hmm. There's actually a space defense council or something like that. Which sounds like fun. Yeah, it sounds sci-fi, doesn't it? Sound.
Get a cool uniform and a hat.
I know, with a special badge that you tap to communicate with. So, yeah, it's like you think it's like a planetary defense system, like for aliens landing on the Earth, but no, these are kind of like real aliens that are going to crash land on the Earth, and the crash landing is going to be pretty hazardous. Yes, that's what we got to look forward to. I'm not going to put a picture of the sun up because it is blank.
Nothing to see here, folks.
Like really, really blank. Yes, not one spot at all in the sun right now. There is a bit of a coronal hole in the northern portion of the sun northern hemisphere, and that is allowing a stream of particles to flow through space. We're just starting to enter it, so the solar wind activity is a bit up. Solar wind speeds are 470 kilometers per second. That's moderately fast. The density is moderately low at 5.45 protons per cubic centimeter. So if you live somewhere around the Arctic Circle or Antarctic Circle, you should be picking up some aurora right now. So there's definitely some nice pictures of that. I think you can go to Space Weather. They've got, somebody got a picture flying in an airplane of the aurora.
Cool.
Up around the Arctic Circle. It was the Arctic Circle area. Flying from Denver to Reykjavik. Is that in...
Nice.
Where's
Iceland.
Reykjavik?
Iceland.
Okay. I just wanted to go to Iceland.
Me too. My husband has a friend who's going, and I was just saying, wow, we've never been out. We need to go.
Yes, I think so too. Now, the question is, when you go, do you take that nice warm summery weather, or do you take that dark sky
Well, it
winter
depends
weather?
on what you're going there for, of course.
I know.
So if you're trying to time the northern lights or something like that.
You have to go when it's a little bit darker. So
Right.
maybe spring or fall would be a good time. Or if you want to go, traveling across the country to see some volcanoes and glaciers and stuff like that, and splits in the middle of the Earth. You want to go in the warmer weather, we can go traveling across country.
Yeah, I would probably do the spring or fall thing. I'd like to hit a nice balance between shooting for the skies and facing up to the reality that you are not guaranteed to see the northern lights or anything like that. So you may as well have some daytime activities to pursue.
Mm-hmm.
And I'm not really into skiing or cross-country skiing or anything.
Yeah. Would be nice to go hiking the countryside, though.
Oh, yeah.
As long as it's
So
not
I hear it's gotten really crowded since they
too
started
far.
filming certain TV shows up there.
Oh, what TV shows are they?
I think Game of Thrones.
Oh, really?
Yeah.
Being starstruck. Uh-oh. Can you take over for a second? I got to deflect a call.
Absolutely. So, rather than talk about the sun, since there's nothing really to discuss, I'd like to do a shout out to an undervalued, underloved manned spaceflight mission because it is the anniversary of the launch of Apollo 7. Apollo 7 was a little unique. It was the return to flight mission for the Apollo astronauts following the disaster of Apollo 1, in which, of course, the three-man crew was killed in a fire on the ground. And it was testing out what would become the command service module for moon missions. It was an Earth orbit mission, so it was launched not using a mighty Saturn V rocket, but the smaller Saturn 1B. First time a Saturn 1B ever put a crew into space. It was the first three-person American space mission. The Soviets had, of course, done it first.
Mm-hmm.
And they did a live broadcast from TV. And they did a thoroughly successful flight from a technical standpoint. Now, one of the reasons it's a bit underloved, other than it was a Earth orbit shakedown rather than going to the moon, was the crew got stroppy. Specifically, the commander, Wally Schirra, got a head cold. He was not feeling like a particularly happy-go-lucky astronaut. And his crew members were affected by the malaise, you might say, and also by the congestion. And so they got a little snippy with ground control. It was called a mutiny. I really wouldn't call it a mutiny because it was a real mutiny later with one of the Skylab missions where the crew said, you know what, your schedule that you came up for us is garbage and we are not going to do this.
Yep.
Whereas the Apollo 7 guys, they were talking back to mission control. They didn't like the food. They had some motion sickness. The Apollo capsule was much more spacious than astronauts had been used to, and so they got a bit of motion sickness. And they were dealing with things like the waste collection system. And I don't mean the fuel. I mean the human waste collection system, which was very unpleasant to use. So you've got astronauts with head colds and bathroom issues and motion sickness all in one go. You're going to have a very miserable crew.
And grouchy people anyways.
Yeah.
For not feeling well.
Who would like that? So, you've got lively comebacks to mission control, like, we don't have the equipment out. We've not had an opportunity to deal with it. We've not eaten. I have a cold. I refuse to do this. So, yeah, so they got in a bit of trouble. So Wally Schirra never flew again, but he wasn't really planning on it. There was his third space mission. He'd done Mercury and Gemini and Apollo. The other two guys, the junior guys in the crew, I wouldn't say they were blackballed the way some astronauts were blackballed formally, but they never got to fly again either.
Mm. Well, yeah, and that's like that era of overmanagement too sometimes,
Yeah.
That caused other errors to show up, and when management got blackballed too.
Right.
Later on.
Right. So anyway, it was I enjoyed the mission because of the human dynamics, and honestly, after what happened with Apollo 1, being the first crew to get into the command module and go up there and see if it was going to succeed, that took a lot of guts.
Mm-hmm. Yeah, so I was thinking, like, well, after Apollo 1, then Apollo 7 would have like a bit of reason to be a little extra cautious. And
when your friends die,
yes,
and your job is get in the capsule and do your thing, you're gonna not be in your happy zone.
Yes,
and they weren't.
Yep.
But they did their science. They, like I said, from a technical standpoint, the mission was very successful. From a human factor, that's where the trouble came in.
Mm-hmm. Such is life with people.
Indeed. That's why robots don't talk back. Curiosity never has a bad day.
Yeah, let me tell you about robots, okay?
Okay.
So a half hour before the show's supposed to start, my computer decides to upgrade. So, yeah, robots have issues too. That's why I'm considering my computer like a robot. So, yeah, I sitting there and I'm wondering, okay, how long is this going to take? Is it going to be a 5-minute upgrade or is it going to be a 45-minute upgrade right when I'm getting ready for the show? So, yeah, robots can have an attitude too.
Yeah, my Roomba is hiding out under the couch. She never made it back to home base after cleaning the floor last night.
Fortunately, this is only a 10-minute upgrade. Now, does your Roomba keep spinning its wheels so it burns up and catches your couch on fire? Or will it shut down when it's locked in?
It depends on what the problem is. If it hits a physical obstacle, it can keep spinning until the battery runs out. But most of the time, the sensors indicate that something is not right, and it just shuts down. And it sends, if I'm in the house, it'll give me a little message saying, please move me to another location. Uh-huh. And if I'm at work or I'm out and about, and I'll just come home to find it sitting there dead.
Of course, you have to find it like a cat, too, by looking everywhere for it, right?
Oh, yeah. Yeah, one time I found it. It got killed by the Swiffer mop. So it knocked over the Swiffer mop and then tried to run it over, and it got stuck with its wheels off the ground and died. And so I joked that it was the digital tool was defeated by analog technology.
It must have got on the mop head, the stringy part, right?
No, it was on the. It was trying to climb. It was trying to climb over the stick.
Okay.
And that lifted it off the ground, and it stopped.
Uh-huh. And that's just such a simple. Even calling it a robot is on edge, but sort of. Oh, let me tell you what's up in the sky this week. Of course, tomorrow we've got last quarter moon, so you should get a little bit of early observing in some dark skies until the moon rises. It's usually about 2 a.m, something like that. Then your skies are kind of gone. Sunday we've got Regulus be 0.2 degrees south of the moon and an occultation in some parts of the world. I had that listed where it would occur, but I lost that list. I'll see if I can pull it up later. Next Tuesday, Mars 1.8 degrees south of the moon. Next Wednesday, Venus 2 degrees south of the moon. And just for the heck of it right now, next Thursday, Uranus will be at opposition.
Nice.
Up all night long.
So what's its expected magnitude?
Of Uranus?
Yes.
Let me click on it, and let's see what they have it listed as. My star chart up here. And Uranus, magnitude 6.03.
Okay, so this is an ideal time for an attempt to do naked eye observing of the 6th planet.
Yes.
Lovely. Can't wait.
It's not in a heavy star field zone, so you've got a good chance of picking it out. There is a kind of a nice, let's see what magnitude, nice triangle that it's nearby. Let's see what these 4.25 in Pisces 4.8, 4.45. So about a 4.5 magnitude triangle in Pisces. Let's see, where's that at? Trying to back off and zoom in a little bit. Oh, it's part of one of the the western fish. The triangle is. So some of one of the arms, that goes down to a V and goes up to the east. One of the arms is part of a triangle, 4th magnitude star. So you can find that 4th magnitude triangle, and then we'll go to your star chart and figure out where it's at, and that would be a pretty good indication of where it's at. Now, there are a few other 6 magnitude stars in the area. Let's see, there's quite a few, but reasonably separated. So you should be able to pick out which one is Uranus and which one is not Uranus. A few stars there, a few of them 6 magnitude, right next to a 4th magnitude triangle. Possible. Yeah, it's easy to see the fourth magnitude. Now, this is rising of the east right now, so I'd give it quite a few hours for we'd be well up away from the murk of the horizon before trying to see it. Let's see okay, let's see. I've got the map backed up. All right, it's near the lower portion of the circlet. Let's see. So
okay.
what's the lowest star in the circlet? Is Alpha Pisces. All right.
Okay.
So from Alpha Pisces, go up 1, 2, 3, and 4. 3 and 4 up the western arm. 3 and 4 stars are part of the triangle, and it's just to the north of the triangle, a degree or so. Definitely possible. Get a good star chart and kind of get your binoculars out. Definitely, I would say try to see it in binoculars first. It's generally easier to do that. Yes, go ahead, cheat a little bit. See
and then you can detect the disk, hopefully.
Yeah.
6 magnitude, you should be able to detect some kind of solidity to it.
More like color. You'll be able to see
color. Well, yeah, it should be like nice misty green.
Yeah, greenish, bluish color to it. See it, spot binoculars, and get to know the star pattern. Get to know the other 4 triangles. The other 4 stars, which forms. Oh, this is kind of cool. Let's see. What's it called when you take a pyramid and you chop the top off so you get the 4 stars? What's that called? Not a rhomboid.
And you chop the top off.
Okay, let's see. We'll take a triangle.
Trapezium, like a solid trapezium, a trapezium-shaped prism.
Yes.
Okay, a trapezium-shaped
there you
prism.
Go. Okay,
All
so
right.
the 4th magnitude stars form a triangle, and Uranus is part of a trapezium.
Okay.
One of the stars of 6 magnitude trapezium.
Not to be confused with the actual trapezium in the Great Nebula of Orion.
That is correct. Which is rising a little bit later.
Yeah, don't look for Uranus there.
That's correct. We'll get there eventually. So. We've also got, this time of year for Northern Hemisphere observers, the Pleiades is starting to rise out of the east, too.
Yes, what a nice sight.
And towards the northeast, the bright star, listeners in the Northern Hemisphere, if you're wondering what that bright star is towards northeast, low, near the horizon, the early part of the evening, that is Capella.
Capella!
Part of
Lovely
the constellation of Auriga. Yes.
Capella actually disconcerts people. It disconcerted me at my very first star party because it was one of those things where you're up a bit too late and you've probably taken a nap and you're a bit groggy towards dawn and this thing comes up and it looked red. The horizon must have had enough of a cloud layer that instead of being the distinctive yellow that it is, it looked red. And I'm staring at this thing and going, that's Mars, but it can't be. It's in the north. And so it was a very disconcerting 3 a.m. moment. And we were at our big astronomy event a weekend before last, and it was rising over the lake. And it was shooting off so many colors from the atmosphere that people were pretty impressed. And what is that? Why is it flashing red and green and blues? Capella does some nice things. It's bright enough.
Capella is almost a perfect 0 magnitude star.
Yes.
0.05. So it's pretty impressive in the evenings. One that hits the horizon a couple times, rising, and in the northeast, and then it'll also be on the horizon sometimes parts of the year, setting in the northwest.
Well, and for some people, it is circumpolar. It is not circumpolar from any observing site in Michigan, because we do have a friend who tested that, at least in lower Michigan, but I believe it's technically circumpolar from the state that we're in, and it's certainly circumpolar, to the north of us.
Let's see. Declination is listed as 45.59. 45 degrees, 59. So let's make it 46.
46.
Degrees.
46 so that would be from the lower peninsula of Michigan. I believe it's technically circumpolar, but keen-eyed observers that I know have not been able to see this with their own eyes.
So it should be circumpolar for us then.
Yeah,
right.
But if we went up to the UP
by like 3 degrees.
Yeah, get in the car, go to Ontario, enjoy.
Well, anywhere we got a really good north horizon.
Well, there's lakes.
Yep. So
there's a rather big lake due north of us, actually.
Lake Superior. Well, that gets you farther north, though, so that's not good.
Yeah.
So we need something where we can look across a lake, really good horizon, dark skies, maybe from what we call the tip of the thumb. That's Lake Huron, Michigan. So somewhere around there, you might be able to look across Lake Huron, and to get a view down to the horizon.
Thumb, though, you're only talking about 43, maybe 44. You got to get up to Alpena or Gaylord to hit the 45th parallel.
Yes, but then the star becomes less circumpolar. It gets lower to the. Does it get lower or does it get higher? No, wait, farther down. Oh, wait, it should be 3 degrees below our horizon.
I'm saying you got to keep going north. That's why I'm advocating getting in the car and going to Ontario. Well, I realize Ontario is technically south of us, but I mean,
that's what I
mean up Lake Superior way.
All right,
that would be a fun challenge to do from the shores of Lake Superior.
Mm-hmm.
I do not think, from what I have. From experiences that my friends have had, I do not believe it is possible from the Lower Peninsula.
Okay. Let me whip on my star chart here, and I've got it set for us, which is approximately Chicago area. And according to the star chart, it's above the horizon. Try to remember, let's see. If Polaris is 42.5 degrees up, is it? But it's at one of the culminations.
I think we need to arrange for a field trip to the Headlands Dark Sky site.
I think so too.
Yeah, let's do it.
Do a little bit more research on this one and see if
field
it
research.
is.
Field research is necessary.
Yep, according to the star chart that I'm using, technically it looks like it's above the horizon, but at 46 degrees, I don't know if it is or not. I have to do some more research on that. I always get sometimes the backwards. Which side of 45 are things on around here? On the north side of the 45 or the south side of 45? Even Polaris is not dead center, so it's about 3/4 of a degree off the actual pole. So sometimes Polaris is, it's always south of the pole. But the other determination is what's called culmination. When it's on the meridian, the line between north and south, sometimes it will be below the pole on the meridian. That's called lower culmination. And sometimes it'll be on the meridian at a higher altitude above the pole. And that's called upper culmination by about 3/4 of a degree. So sometimes, Polaris actually, a degree and a half, makes a degree and a half radius, diameter circle, 3/4 of a degree radius circle around the pole. Oh, well, I figured it out, and I'll work on that a little bit more, and then we'll make it a challenge maybe to our own astronomy club, and see if you can actually see Capella from Michigan. At least how far
Lower
south
Michigan. Yeah, how far south can you see Capella?
Yep.
I like it.
Yep. Give it a shot.
Cool.
My property up north would not be good because mine faces the south. It's the low in the valley is the south. Behind me, the hill rises up a little higher towards the north, so I don't get very low to the horizon at my property.
Yeah, we're just below the 45th parallel from where we are, but we have a northern horizon. It's a good eastern horizon.
Mm-hmm. All right, that's a project. A couple of projects this week for people to observe the asteroid passing by, and Northern Hemisphere observers Capella.
And naked eye Uranus.
That's true, naked eye Uranus.
Opposition.
Yep. Since we're talking about what's else in the sky, let me just kind of whip around here.
I think we've whipped around to the bottom of the clock, Marty.
I think we did whip around the bottom of the clock. So that means you are listening to Space Pirate Radio here on Astronomy.FM. It is another Wednesday evening. This one is October the 11th, 2017, at almost 9:30 in the evening for those of us here in the eastern portion of North America. So Universal Time would put it at 1:30 in the morning, October the 12th, Thursday morning, 2017. And, of course, I want to remind everybody that we will repeat this program every 4 hours for the next 24 hours. So you might actually be listening to us on the repeat. If you're listening to us live right now, come on over and join us in our Astronomy.FM chat room. Go to the homepage. You'll see where it says Radio Chat. Just click on that, and you'll be here. So if you want to ask us questions, just type it into the chat room, and we'll try to see it, catch your question, and answer it for you on air. Let's say hi to everybody that's in our chat room. Of course, we consider you part of our Space Pirate crew when you're in the chat room during the live presentation. So we got you and me, of course. We got Glenn, Twist Edge, Aqua for You, Doug at Northern Cross Observatory, Plaid Joan, Optronics, Plaid Sister, and Plaid Mac. Glad to have you all here, everybody. All right. Oh, and don't forget, upcoming program, we should have our usual rundown of Astronomy Ireland, Planetary Radio, Naked Astronomers, Naked Scientists, all coming up after Space Pirate Radio. Launch coming up to the International Space Station, and let's see, what is that? There it is. Russian Progress cargo craft will be launching tomorrow morning, actually. Let's see, it's 9 o'clock here, 5 o'clock in the morning, so about 8 hours from now, approximately. You can go to NASA television and watch that. So whatever your time is, the live presentation. Let's see, so 8 hours from 1:30 is approximately 9:30 Universal Time when it'll be launching. So I've never actually watched one launch. It's a little too early in the morning for me.
Launch of what specifically? Any launch?
Well, the Russian.
Oh,
launches.
the Russian Progress launches. Yeah.
Yeah.
The only launch I've seen is a space shuttle. Though we did a stakeout. My husband and I did for. I want to say it was Maven.
Okay.
It was one of the large rockets being launched at night from Wallops Island, and technically speaking, Detroit should have been at the theoretical limit of visibility.
Kind of like Capella.
Yeah, you're right. Yeah, and so we had about as much success. So we did the stakeout and got fooled by a plane. That was kind of amusing. Since Detroit has a very busy airport with so many aircraft coming in and out, we saw something that looked weird, and then we realized it lasted way too long for a rocket launch. And no. But no, I think the only thing I've actually seen to date is this final space shuttle launch.
Would you know, is there still a restaurant on top of a building we used to call the Renaissance Center?
It closed earlier this year. It's supposed to reopen as something else.
Okay.
So yeah, the restaurant was called Coach Insignia. I liked it actually, but some of my friends loved it. And it closed down at the beginning of the year, and supposedly there's going to be a new one reopening. So he's asking because the Renaissance Center is the largest, tallest structure in Michigan.
At least in our area. Oh, it is all Michigan, yes.
I thought it was all of Michigan because they tore down the power plant smokestacks that were about 25 feet taller.
Okay.
So I believe it's 700 and something feet up in the air.
62 floors, if I remember.
Yeah. So it is from that restaurant, you have one heck of a view. So you're saying when they're doing a nighttime launch for Wallops Island, book a romantic table by the window of the restaurant.
Now, it used to rotate, I think.
It does not rotate. I don't know if they're planning to restore that, because I've been to quite a few rotating restaurants that are still in business, most recently in Seattle at the Space Needle, which was awesome.
Mm-hmm.
Yeah, if you would like to celebrate the space age, there's a reason it's the Space Needle. Mm-hmm. And so when you go in, you get to see this whole display as you're waiting in line as to the building of it and the concept art and everything like that. And right down to the scheme of the paint. It was called things like Astronaut White and Galaxy Gold. So it's this absolutely endearing early 60s space age geekery. And the food was good too.
Doug said it did rotate when it opened. Yes, I remember it rotating in the early 80s.
I was there 3 times in the last decade, and it was not rotating at that point.
Okay, I should remember it. Yeah, it stopped rotating quite a long time ago, but I do remember it rotating in the early 80s because I did go up there for dinner one time. Rotating. Not rotating would actually be good. Now, definitely you could plan a a dinner there on a really clear night. I mean, if you check the weather, if it's clear all the way to the eastern to the east of us, go up there for a dinner and potentially see a rocket launch from the window and get a good, be able to pick your table number. Sounds like it's got a little bit of a plan for a astronomy rocket launch. Dinner would be pretty nice. Maybe get a few people to do that.
It's a lovely idea. Yeah, so now we just have to figure out the next one for Wallops Island.
Yep, and when the restaurant opens.
A big one for Wallops Island.
Yeah.
So they do a lot of launches there that you wouldn't be able to see, but this one was a craft bound for Mars. Uh-huh. So consequently, yeah.
All right, so that's a future plan if they open that restaurant again. And getting in contact with the restaurant for some potential opportunities to, publicize a dinner at that time.
Well, I do know a friend who does some conferences of the sci-fi nature there at the Rensen.
Oh, yeah?
So he's done some observing from fairly high up on some of the floors right below the restaurant, if I recall. So, yeah, there's some ways we can play it.
Was there an outdoor observation deck there, I wonder?
You'd have to talk to him.
Okay. That's a plan. So that's a plan. It's a project. Would it be about a few hundred miles away, isn't it? More than that. 700 miles, 800 miles away? And we'd have to have a launch that would generally not go due east. But that would get the rocket plume right at us. That'd be interesting. It's one of those things that if you mix the rocket launch, you still have a nice dinner.
Exactly. Yeah, it's like when you went to Hawaii for that solar eclipse that you didn't get to see.
That's right. But I did get to see Hawaii.
You got to see Hawaii.
So that was an okay trade-off. Not a great trade-off, but an okay trade-off.
So doubling back to the conversation we were having before the station break, Glenn in the chat room wanted to know, okay, so we're trying to figure out how far south you can go and see a circumpolar Capella. How far north can you go and see Omega Centauri? And I happen to have some firsthand information on that.
Okie doke.
Because I've had some contacts with the Royal Astronomical Society of Windsor, Canada, who have a dark sky observing site at the southernmost point of Canada. It's Point Pelee National Park, which is smack on the 42nd parallel.
Sticks into Lake Erie.
So you have a lovely dark flat horizon. And for a couple of nights a year in March, I do believe, you can see Omega Centauri, according to their club and their club's archives. So that is one of my bucket list challenge items.
Mm-hmm. I've heard of that. I've tried it, but couldn't see it. Too much haze. So the sky conditions have to be just right.
Yeah.
But it's possible.
But theoretically, it can be done from 42nd parallel north. And I make no guarantees for anything above the 42nd parallel, because that is a very special site with the flat lake. I mean, you are on a peninsula sticking into the lake, so you've got a 3-way flat horizon.
Yes. However, stay away from the water at the very point.
Absolutely. Swimming. Do not go swimming there.
Do not go wading. Don't walk.
Do not go wading. Stay out of the water. Yeah, thank you. That is a fool's game.
I've heard the current there will, if a few feet out in the water, will drag you offshore and down while you're
not every day, but I've definitely been there on days when it was entirely possible. I mean, when you see that water surging, because you've got the eastbound current and the westbound current, and that's why there's a peninsula. They're colliding. They're dropping silt. And, yeah, you don't want to do that.
They smash, swirl, and plunge.
Yeah, people die. Yep. There's a memorial to a 16-year-old boy who drowned there some years back.
Mm-hmm. I haven't been there a long time either. I need to do that.
When you go, walk down the tip and check out the benches, and you might notice a familiar last name, because the second bench from the tip is in honor of my husband's grandmother.
Oh, nice.
Yeah, so, yeah, we like that place.
Mm-hmm. Just have to check and see how friendly the border crossings are lately. I don't have no clue.
I have a Nexus card. It's sweet. Mm-hmm. If you take your telescope, they might think you're bringing over some kind of bizarro weapon until you explain yourself.
Mm-hmm. Hopefully they know what you're talking about.
Well, yeah. I mean, I think that at this point they know that we're the weirdos with the astronomy gear.
Okay. Let's see. What do we got here? I'll save this one for last. Interesting article. Long article if you want to read a little bit more. Longer technical article. This is from Nature Astronomy.
Okay.
About the New Horizons Pluto mission.
Ah, okay. What, about its next destination?
Nope. It's about basically what it's learned about Pluto itself.
Very cool.
The detailed article. So if you want to more detailed, check this article out. We put it in our chat room here. I only got a chance to glance at it, so I didn't see how complicated it was. But I'll read it when I get a chance. I like a little bit more complicated technical articles sometimes. So check this one out.
Well, speaking of dwarf planets, I've got an article that's not nearly so technical. The dwarf planet that you probably don't think about much, Haumea, one of the 5 that are currently recognized as such. It's got a ring.
A ring?
A ring.
Ring or rain?
Ring.
Ring, R-I-N-G.
R-I-N-G.
That has a familiar ring to it.
Mm-hmm. So it's not the first small object to have a ring around it, because there's a minor planet, which is different from a dwarf planet, called Chariklo, between Jupiter and Neptune. It's one of the centaurs in that belt of objects. And it's got 2 rings. And so now we've got Haumea with a ring. And that is now 6 bodies in the solar system known to have rings.
Oh, nice.
Yeah.
Getting into discussion with somebody this week about dwarf planet Pluto and Eris. Have they confirmed that some of the other dwarf planets are actually bigger than Pluto, or still just suspected, not confirmed? Do you recall?
Last I checked, it was in the suspected, not confirmed category, and I welcome correction from somebody in the chat room with hard facts.
That's kind of what I thought too. So it really kind of depends on its albedo. So if it's got a lower albedo and it appears to be fairly, quote unquote bright, then that would mean it's larger. But if it's actually got a higher albedo, that could make it appear to be brighter, but it might actually be smaller.
Right. It's hard to determine. I mean, Ceres in its day, which it was discovered back in the 19th century, and Pluto and Eris all were initially estimated to be significantly larger than they currently are thought to be.
Mm-hmm. Now, if Ceres was as bright as that white salt spot, that would change it too.
Well, now we've got a probe there, so we know how big it is.
And we know how bright it is and everything like that, yes.
But Ceres, thanks to the Dawn mission, has been very thoroughly checked out at this point. Eris, on the other hand, no. We've not sent any probes there.
Exactly. So, a little bit of conjecture there still to be confirmed. Let's see. Here's an article. Did you ever put your name on a space mission? Like to Mars or anything like that?
I want to say that my husband and I did, and I'm trying to remember the mission. I did not myself. I believe Jonathan did.
I thought so too. Okay, another opportunity to do this.
Okay. From
the let's see, the Mars probe. Let's say what's this one? Insight lander. You can travel to Mars. Okay. You can travel to Mars next year. They had one chip on it with names on it, and a couple million people, and they've just added another chip. Cool. So you can put your name onto it. So, but you do it like within the next couple of weeks.
And this is legit. It's through the JPL. So Marty's posted the link to the JPL website. So it's not a scam.
That's right. I don't think it costs you anything. Don't quote me on that. I'm a pirate.
It'll cost you. You don't want to know what it'll cost you.
That's right. Up to November 1st. So submit your name if you want to do that. I thought, well, it's just okay. It's just like, so what if it's my name and it doesn't really mean much.
Marty
anything.
Was here.
I know. I could point my telescope at Mars, and in the back of the telescope, I could put my name. So technically, in a flashlight, my name is sort of being beamed to the planet Mars. Does that kind of work the same? kind of. There's about the same amount of meaning. I could do Morse code with a laser pointer towards the planet Mars. And eventually, it'll get there really faint, but technically it will. I'll have to see if it has to be your actual name, or maybe we can send Astronomy.FM.
Oh, that'd be cool.
To Mars. How about that?
That's some harmless fun.
That's true, too. Oh, let's see. I don't know if I'm not ready for this last article, but maybe I am. All right, let's go for this. Maybe my last article is you got
kill the
something.
Speculation. What have you got, Marty?
Got something. All right. A white dwarf star that went nova.
Okay, good, because I wanted to talk about that one too. All right.
In one of the companion galaxies of the Milky Way. So we're going to start out with talking about companion galaxies to the Milky Way first. Then we'll talk about which one this is in and what it actually is. So hopefully everybody listening to us is quite familiar that we live in a galaxy of a couple 100 billion stars, and there are billions of galaxies like ours. Not everybody knows that galaxies also have smaller galaxies orbiting around them.
They keep pets.
Yes, that's correct. And we tend to sometimes absorb them and things like that. So the Milky Way's got, I don't know, it looks like a good 50 galaxies of various sizes, most of them, of course, pretty small, orbiting around the Milky Way. Sometimes they're kind of partially in the Milky Way galaxy. A lot of times we'll actually shred one of these small galaxies, which might only contain a few 100,000 stars, for instance. And our Milky Way galaxy will actually distort them and stretch them out. So it's kind of hard to tell that it is actually a galaxy being absorbed by the Milky Way galaxy. But there is a good 50 of them with names like the Sagittarius Dwarf, Boötes 3, Sculptor Dwarf, Draco Dwarf, Hercules, Fornax Dwarf. That's kind of a famous one. Let's see. We've got Pisces 2, Tucana 3, kind of along the list. In fact, I've got a list from Wikipedia. Let me put that link, even though you can pretty much find it yourself, but I'll just pop it into our chat room here, so just make it a little easier to look it up. So there's a bunch of them. The most prominent ones are two fairly large small galaxies called the Magellanic Clouds. We've got the Large Magellanic Cloud and the Small Magellanic Clouds. Both of those, by the way, are visible in the evening from the southern hemisphere. So I kind of looked up like around Buenos Aires there, where Optronics lives, and they are kind of low towards the south, getting higher as the night goes on. So it's pretty easy to see them this time of the year in the early part of the evening, actually for the whole evening, because they're like circumpolar and they're actually rising right now. I can't remember if it's on the southeast side. So they're rising higher, and inside these other galaxies, a lot of prominent features. There's star formation regions, like inside the Large Magellanic Cloud, there is the Tarantula Nebula. There's a giant gas cloud being lit up by brand new stars. And that's lighting up the gas, and it's pretty popular. So it's actually very, very big. You might be familiar with the Orion Nebula. That's a star-forming region in our own Milky Way galaxy close to us. The Tarantula Nebula is much bigger, about the size of the entire constellation of Orion if it was in place of the Orion Nebula. Now, there's a star inside the Small Magellanic Cloud. It's a white dwarf star. A white dwarf star used to be a normal star, used up its nuclear fuel, stopped converting hydrogen into helium, and when it did that, it became a planet. Yeah, it's a planetary nebula, and what's left behind to light up the planetary nebula was basically the core of the star. It's now called a white dwarf. It's pretty small, a bit dense, of course, being a core, and very, very bright.
It's degenerate matter, so it's not really fusing anything at this point.
Nope. It's just whatever atoms and molecules were formed at that time, and basically still in the ball. Now, usually they'll spend billions of years as a white dwarf star slowly getting cooler and cooler and cooler because there's no nuclear reactions going on.
And then literally fades to black.
It does, yes. Unless it gets fueled by another star. And how's it get fueled by another star? Well, if two stars were in orbit around each other, fairly close, and one of them uses up its fuel, blows off the outer shell, and becomes a white dwarf, it's still in orbit around a companion star. And if they're close enough, it could actually draw gas from the companion star down onto the surface of the white dwarf. And a couple things can happen depending on the dynamics of the system and how fast they fill up and everything else. It could actually make that little white dwarf kind of flare up. So the surface, the gas is being drawn down to the surface of the white dwarf, can actually flare up. It'll get brighter temporarily and then shrink down. That's called a nova. Some of them are called reoccurring novas. It could happen kind of regularly. In fact, I think some of them are actually known. They can happen every few years, every 10 years or something like that. The star will get brighter for a few months and then dim back down again. Now, the other end of the scale, if it draws a lot of material in very quickly down to the surface of the white dwarf, it can get so much material onto it that it'll actually explode in a supernova explosion, basically destroying the white dwarf, ending up with a most likely a neutron star, and then big massive amounts of gas spreading out into space. This object is a white dwarf. It's in the Large Magellanic Cloud, and it has been determined to be, so far, the most luminous white dwarf eruption ever seen. Small Magellanic Cloud is 200,000 light years away from us. They think that it was right on the borderline of just being a regular nova, burning off that shell of gas and exploding into a supernova. Yes, this one's considered to be right on the edge, so it did not go supernova, but had enough material to be seen all the way from the Earth. Let me put the article into our chat room here.
Yeah, I've got the one from Astronomy.com in there, which is a nice little rundown.
Okay. This is from SciTech Daily, too.
Yeah, it's a very cool story.
Let's see. The magnitude, I think, is still pretty dim. Let's see. I can't remember what they said. I'm trying to read the article here on what the actual magnitude of this object was. But I think it's still fairly dim. I think like 17th magnitude.
Yeah, you are talking about a white dwarf 200,000 light years away.
Yes.
And it's not a supernova.
Yes. One thing that when the novas go off like this, they will produce a lot of X-rays. So they've observed this with multiple different telescopes, including the Swift X-ray Observatory. And also using, telescopes in the southern hemisphere, obviously, because won't be able to see any of this in the northern hemisphere. Yeah. So a collaborative effort to see this white dwarf actually explode and determine, you can't really tell by its light curve how bright it should be and how far away it is, but one good indication is that if it's in the Magellanic Cloud, Small Magellanic Cloud, we've already established the distance to the Magellanic Cloud, that we pretty much know the approximate distance that this is, which really helps determine how bright it actually was if you were like standing right next to it, type of thing.
Yeah, that's a good point. We already know where it is in relation to us.
Yeah, so we know what it can determine its actual brightness. Astronomers will use telescopes and put a like a spectral grating and be able to analyze the light and determine the chemical composition of this nova, what's going on inside of it chemically as it brightens up, and allow us to, again, model the stars and figure out what their composition is and how they react with different chemicals in them when they explode like this. So this one's determined to be the brightest white dwarf explosion. Still has to be totally confirmed that it is in the Magellanic Cloud. I mean, could be a little deception there. Could be inside the Milky Way that this occurred, and so it would make it much dimmer. It is possible to be a foreground star.
Distances are hard.
Yes, but that will be to be determined yet. But they're saying that this one is in the Small Magellanic Cloud, and it would have to be the brightest one they've ever seen of this type. Now, it's quite easy to see supernovas in other galaxies. Amateur astronomers have seen them quite a bit, too. I don't think we'll be able to pick this one out as an amateur astronomer, though.
I'm not going to try.
But you never know. There's some people with some pretty good equipment.
Indeed.
There. Well, you got, for instance, renting a telescope from telescopes.net. Might be
That's
a project
good point.
for somebody to try and see if you can image this object. Give that a shot.
So, in brief, we've got another story about a nearby oddity. In this case, we're talking about an exoplanet around the nearest star to us, other than the Sun, Proxima Centauri. Proxima Centauri B is now being dubbed the pale green dot. So why green? Well, it's not vegetation. It's believed that it would have aurora, northern and southern lights, 100 times brighter than on Earth. So remember, it's orbiting a red dwarf star very close to the red dwarf star compared to, where we are in relation to the Sun, 1 astronomical unit.
Mm-hmm.
These aurorae would be so bright that we might be able to see them on Earth with very powerful telescopes.
Wow.
And if the planet has oxygen in its atmosphere, the auroras may be tinting the atmosphere green. Cool.
That's interesting.
Yeah.
I wonder, is it oxygen that makes green aurora, or is it the nitrogen here on the Earth that makes green aurora?
Yeah, they were zeroing in the paper that was presented at the Astrobiology Science Conference in Mesa, Arizona. They were zeroing in on oxygen auroras specifically.
I obviously am probably wrong, but I thought the green auroras were from nitrogen, and then when you get the more intense particles coming from the sun, you get more of the yellow and red auroras, which comes from the oxygen in our atmosphere. But I guess I'll have to relook that one up and see what they say about that. Let's see. Urkel on a yellow hypergiant.
Okay, yellow hypergiant sounds good to me in the last 3 minutes we got.
All right.
Let's do it.
Yep. The largest hypergiant ever discovered is V766Sen, which I think stands for Centaurus. Yes. Constellation towards
1,400 times the diameter of the Sun, one of the 10 largest stars ever found. Okay, that's pretty impressive.
It is, yes. The color is depending on the temperature of the star itself. Stars can be different sizes and different colors, and that means different temperatures. So you can have a small star that's kind of cool, and it'll be red. Or you can have a really, really large star that's red, and it's also rather cold. Whiter stars, a white star would be actually very, very hot star, but like we just talked about white dwarfs, so they can be pretty small. Or you can actually have a gigantic white star that formed that way, and that would be a very large, very hot star. And those are the ones that don't last very long because they use up the fuel very quickly. Yeah. So this is one that is approximately the color of our sun, but many, many times larger than our sun itself, as the articles is saying. So, and this is, one of the record breakers that we've actually get to see. Is it here? It must be here in the Milky Way. I would assume so. They're using European Space Agency's very large telescope interferometer. So the hard part is determining how big it is. And
probably about 650 times the size of the Sun.
Yeah, it looks like
it's cool because it was they believe that this was a red supergiant which lost so much mass so fast it transitioned back into a warmer yellow supergiant. Mm-hmm. So this thing is so far off the main sequence, it's just doing its own thing.
Yep, up and down, sideways, and all around. Well, everybody, that's about time for us to head on out of here. So appreciate everyone listening in. Don't forget, we'll repeat this program every 4 hours for the next 24 hours with other programming. Don't forget, coming up, Astronomy Ireland also. I want to thank everybody that's been in our chat room tonight. Really appreciate you being here, part of our crew. Time for us to head out. Good night, all.
Clear skies, y'all.
We hope that you've enjoyed this program from AFM Radio, the broadcast service of Astronomy.FM. This program has been released under Creative Commons license. Please contact us for details. You may find more of our AFM original programs on our website. It's really easy to find us. We are Astronomy.FM. You may also find us in the iTunes radio listings near the top of the News Talk section, and also as an iTunes podcast selection. We'd love to hear your comments. Please email us at radio@astronomy.fm. Thanks so much for being part of the voice of astronomy around the world and across the known universe. This is Astronomy.FM Radio.
AFM.